Welcome all the students in Physics by TC Chauhan sir YouTube video. We have again come with 12th board special. Today we shall discuss about radioactivity. If you feel it is very useful for you, then you should like, subscribe and go in the comment section for the comment and share it. Let us discuss about radioactivity. In 12 board special, radioactivity part is very important as far as we concern about the small question as well as big questions. In general, 2 marks or 3 marks questions are asked usually. Let us discuss about radioactivity. What is radioactivity? Radioactivity means the spontaneous emission of radiation from a particular material. Suppose this is a material, it is going to emit few radiations. These are invisible radiations. Due to this emission, the mass of the element go on decreasing continuously. This phenomenon is known as radioactivity. The phenomena of spontaneous emission of radiation and continuous decrease in the mass due to splitting of atoms, that is known as radioactivity. Question arises, who discovered radioactivity? Radioactivity was initially discovered by Henry Becquerel and experimentally demonstrated by Marie Curie. And further, radioactivity can be of natural or can be of artificial type. Now, let us discuss about radioactive radiations. There are 3 kinds of radioactive radiations. If we discuss a radioactive material which is kept inside a box which is made of lead for safety reason, then 3 kind of radiations are emitted which can be captured by using particular electric and magnetic fields. If we discuss about electric field, then there are 2 plates. One is positive plate, other is negative plate. Toward negative plate, the radioactive radiations will be alpha radiation, and toward positive plate the radioactive radiations will be beta radiations, and few radiations will not deviate at all towards electric field, and these are gamma radiations. Now, this experiment indicate that the radiations which are deviated toward negative plate, these are alpha radiations which are positively charged. In fact, alpha radiations are helium nuclei, that is 2He4. This is alpha particle or alpha radiation. But if we discuss about beta radiation or beta particle, it should be electron because it is negatively charged particle and attracted toward positive plate. So these are 3 kind of radiations. Gamma radiations are basically the photons which have no charge, no mass. It means it is not deflected either by electric or magnetic field. These are few concepts. Now we discuss about few properties of alpha particles. Listen students, alpha particles are basically positively charged particle. These are helium nuclei. Their charge is twice charge of proton. Their mass is 4 times mass of proton. These are deflected by producing external electric field or producing external magnetic field. These can produce fluorescence. These can affect photographic plate. Their ionization power is very high, but their penetration power is very low. This is about alpha particle. Now we shall discuss about beta particles or beta radiations. In the case of beta radiations, these are negatively charged particles. These are electrons. Their charge is equal to charge of electron. Their mass is equal to mass of electrons. These travel comparatively speeder than that of the alpha particles. These can produce fluorescence. These can affect photographic plate. These are captured by particular ionization field. These produce fluorescence. These affect photographic plate. Their ionization power is less than alpha particles and their penetration power is more than alpha particles. This is about beta radiations. Students, now we discuss about properties of gamma radiations. The gamma radiations are basically photons. So their charge is 0, their mass is 0. These are not deflected by electric and magnetic field. Why? The question is, these are not having any charge. That's why it will not get deflected. The other thing is, these produce fluorescence. These can create these can affect photographic plate. These travel comparatively with higher speed, which is almost equal to speed of light. These radiations are very useful when we concern about penetration power. Their penetration power is very high, while their ionization power is very low. This is about properties. Now, what about decay? Let us discuss about decay of alpha radiations. Whenever alpha particle is going to decay from any substance, suppose substance is ZXA, through which when alpha particle is going to decay, that is 2He4, then the remaining material will be Z minus 2Y A minus 4. That means a new element will form. This element was X, this element is Y. New element will be formed. Atomic number will get decreased by 2. Mass number will get decreased by 4. Now, when alpha decay takes place, then the concern is about what will be the spectrum. Its spectrum will be characteristic or line spectrum. It will not be continuous spectrum. Remember, this is very important for short question. Now we discuss about beta decay. In the case of beta decay, it is observed that when we have particular substance ZXA, through which when beta particle decay, that is minus 1 E0, it is beta particle, then the new element will get emitted, and that will be Z plus 1 YA. This new element formed will have atomic number more than the previous one, but mass number will not change at all. Now, what about the spectrum? Its spectrum is continuous. The main question arises that nucleus is a positive charged body. Then how beta particles, which is negatively charged and it is said to be electron, how it can be emitted? Then neutrino hypothesis was given, in which due to interconversion of protons and neutrons, there will be emission of beta particle along with positron. Whenever a proton converts into neutron or neutron converts into proton, then such emission takes place, and this is continuous spectrum. This is continuous process, so its spectrum will be continuous spectrum. This is about beta. Now the question arises, what about gamma decay? Gamma decay is not follow any such changes. Like ZXA is there. Whenever gamma decay takes place, that is 0 gamma 0, then again there will be ZXA. Atomic number does not change, mass number does not change. It means during gamma decay there will be no change in atomic number and mass number. That shows that during this process there will be excitation of nucleus, and due to this its spectrum will be line spectrum, not continuous spectrum. Now we shall discuss about few laws of radioactivity. Radioactivity basically has two laws given by Rutherford and Soddy. The first law is a theoretical law. It shows that radioactivity is totally spontaneous and self-process, in which atom is going to decay and when it will decay, it cannot be predicted at all. Which atom is going to decay and when it will decay, it cannot be predicted. It is totally self and spontaneous process. This is first law. Now, second law about rate of decay. Rate of decay of radioactive element is always directly proportional to number of active atoms, like minus dn upon dt proportional n. Then dn upon dt is equal to minus lambda n. This lambda is known as decay constant, and lambda is decay constant. Its unit is number of decay per second, that is, you can say second inverse or minute inverse or hour inverse or day inverse or year inverse, you can say. This is about lambda. Now it has a particular decay law, and that decay law is exponential decay law. It can be derived from this law. Listen students carefully, it is very important. We know that according to second law, minus dn upon dt is equal to lambda n. Then dn will be equal to minus lambda n dt. Then you can write in this way, dn upon n is equal to minus lambda dt. Take integration both sides, you will have log n e base is equal to minus lambda t plus c. Here c is a constant value. If you take initial values, then t will be 0, then n will be equal to n naught. Then we will find that log e base n is equal to minus lambda t plus log n naught. Then you will have log e base n upon n naught is equal to minus lambda t. Then n upon n naught is equal to e base minus lambda t, and this is exponential decay law. N is equal to n naught e to the power minus lambda t. It is very important law. It can be kept in terms of half-life. Question arises, what is half-life? Half-life is basically the time during which a radioactive element becomes half of its original value. Like exponential decay law, n is equal to n naught e to the power minus lambda t. In the case of half-life, n become equal to n naught by 2 when t become equal to t half. Then by putting these values, you will have the result t half is equal to 0.693 upon lambda. It depends upon decay constant, and it is 0.693 ratio of decay constant. It is very important in the determination of ages. Now, what about average life? Average life or mean life is just reciprocal of decay constant. It is average of lives of all the active atoms. Now, what about activity? Activity or radioactivity, you can say it is rate of decay. A is equal to minus lambda n. It is very important as far as we concern about numericals. A is equal to lambda n, you can say dn upon dt. This sign will be positive. A will be equal to positive of lambda n because rate of decay is given in terms of negative sign. Students, it is very important for numericals. In this way, A is equal to lambda 0.693 upon t half into 6.023 into 10 to the power 23 small m upon capital M. Now, what about t to the power half? It is half-life. Now, what about small m? Small m is mass of radioactive element. Mass of radioactive element. And what about capital M? What about this capital M? Capital M is mass number, or you can say atomic mass. So this is used for the numericals. Now, what about the units of radioactivity or activity? Unit of activity is disintegration per second. It can be becquerel. Same thing, either disintegration per second or becquerel. Other units are Rutherford, or you can say Curie. 1 Rutherford is equal to 10 to the power 6 disintegration per second. 1 Curie is equal to 3.7 into 10 to the power 10 disintegration per second. This is all about activity. Now, what is decay curve? The question is, decay curve means the graph between number of active atoms and time of decay. Whenever we draw a graph between number of active atoms n and time of decay t, it will be exponential curve. Why it is exponential? Because the relation for decay is n is equal to n naught e to the power minus lambda t. One more formula is very important for solving numericals. and that is relation between number of active atoms and half-life. This formula is like that. It is in this way. N upon N naught is equal to 1 upon 2 power small t upon capital T half. This is very important for numericals. Let us discuss about numerical, which is very important. Like, if any radioactive element become 1 upon 32 times in 5 years, what is its half-life? Now, how to solve this question? Very simple. N upon N naught is given to you, that is 1 upon 32. And 1 upon 32 can be written as 1 upon 2 to the power 5. Then it will be 1 upon 2 small t upon t half. This small t is 5 years. Then take comparison of these two powers. Whenever bases are same, then power will always be equal. That is, small 5 is equal to small t upon t half. You know, t half will be equal to 5 upon 5, and this will be the 1. This will be the answer. That is, half-life of this radioactive element is 1 year. So such kind of numericals are asked. Now, what about the logical question based on that? Few logical questions are very important, and these logical questions are: what are the uses of radioactive elements? First use is in the determination of age of old fossils or dead animals or dead plants by using carbon 14, by using process carbon dating. The second use is, it is very useful in the treatment of cancer patients. It is very useful in the determination of actual position of the old things like statues, like ancient walls, etc. It is very important whenever you concern about the fuel of any radioactive isotope, that is uranium-235 is used as fuel of nuclear reactor, atom bomb, etc. It is also used in breeder reactor for the production of useful radioactive isotopes in medical science. So these are few uses of radioactivity. That's all about radioactivity. Students, please do subscribe, like and share my video. It is board special. It is for board aspirants. That's all.